All right, I think we can go ahead and get started in the interest of time. Good evening, everyone. I wanted to thank everyone for joining us this unusually warm summer evening. And I wanted to go ahead and introduce myself. My name is Sony Johnson. I'm with Alameda County Healthy Homes Department. And I have the distinct pleasure of introducing our guest speaker tonight. His name is Rob Bennington, and he is from UC Berkeley's Cooperative Extension Program of the Bay Area Agriculture. He is an agricultural advisor that supports small-scale food growers, and he also extends knowledge on urban gardening, as well as soil quality and resource management. He provides urban agricultural policy and planning, and he also teaches urban soil management along with heavy metals exposure prevention, and he works with local groups on mapping urban food growing sites in the East San Francisco Bay Area. There is one located close to my house. So I definitely, hopefully Rob will share some of those resources with people at the end. And he specializes in providing technical assistance and urban agricultural community garden site governance. So again, without any further delay, here is Rob for our Soils One webinar.
All right. Thank you ever so much, Sonny, for that wonderful introduction. Really appreciate that. And you have a SurveyMonkey questionnaire link in the chat asking if you could just complete that to get us a little bit going if you haven't already seen it. And if you need it to be resent, it looks like it was already resent just now. So with that, we're going to dive in. I'm going to pull up the presentation on the PowerPoint. Give me a hot second. All right. And so thank you everyone for joining us tonight. Here we go. This is called Improving Your Soil Quality for the Urban Food Grower. And that site there in the image is historically Wow Farms. It's now part of the Acton on Verba Youth Farm Project. This particular site is in West Oakland, very close to the post office off of the 7th Street Oakland BART station. Soils form over millions of years as a result of long-term weatherization and glaciation. In California, a lot of the state was actually not under glaciers in geological time, but we get a lot of our soil quality from the parent materials of the rocks from which they formed over time. This process of weatherization and glaciation actually carried water and rocks and soils downstream and in the low-lying areas across long spaces and geological time and geographic spaces over time ultimately. And the key concept here with this is that soils are derived in terms of their particle size and their density, right, from the parent materials from which they come. And sedimentary rock formations historically are under large waterways like lakes and oceans. Igneous rock formations are largely derived from cooled and dried lava. And then metamorphic rock formations are those that have been under very, very strong pressures over historical time. And when thinking about metamorphic rock, I might be aging myself, but if anybody remembers when Superman and Christopher Reeve takes a piece of coal and he squeezes it, I don't know if you remember what it turns into. Does anybody happen to know? Does it turn into, it turns into a diamond. Very, very good. Thank you, Sony. And so the key concept here is that particle sizes derived from the original rock formations and combined with pore size, the pores we're talking about in the soils, and organic matter really contribute to what's called aggregate stability. Gonna ask everybody to enunciate out the word aggregation, right? Aggregation in terms of soils is how well a soil holds together when it's wet, how long or how well it holds together when it's dry. And soils form over millions of years in what are called horizons, just like the horizon when we look out at the sunrise and the sunset, right? But in urban areas over long periods of time, topsoils have often been removed, those A horizons, as you can see here. And depending on where you are and what part of the world, those soils may be from anywhere from 6 to 12 to 18 inches deep. And so oftentimes in urban areas, after an urban area of human settlement has ultimately been developed, you have what's left, some part perhaps of some of the topsoil, but often one is starting with the subsoils, the B horizon underneath. And in some cases, those may be clay or hard pans. And then underneath those, you have the parent materials and then the bedrock. So think of an urban area as it's developed. You have the building of residential and commercial land uses. And ultimately that top layer, that A horizon, is usually historically that horizon that has the most organic matter in it. When we talk about organic matter, we're not necessarily talking about the National Organic Program. We're talking about materials that were or are alive, that have a history of being alive at one point and or are contributing to the soil quality in its current state. So your goal is a dark, rich, crumbly soil that holds well together when it's wet and lets it go when it's dry. And in thinking about urban soils, you want to think about how variable they may be across small areas of space, even in a yard, for example, from one spot to the next, right? And then what are the four main things that plants need? So let's think about this for a second. They include sunlight and water, right? The energy and the hydration that plants need in order to grow well. And then also nutrients in terms of macro and micronutrients. Also, when thinking about nutrients and specifically the macro and micronutrients, what does that sound like to you, right? In terms of the plant's needs. In most cases, micronutrients are those smaller, less needed trace elements, right? Iron, boron, can everybody say the word molybdenum, right? Molybdenum is one of those nutrients that's almost never deficient in soils, but is sometimes deficient in greenhouse growing situations. And macronutrients tend to be those nutrients that are needed the most by plants comparatively. And those that we know the most well a lot of the time because of fertilizer packages tend to be the NPK, the nitrogen, phosphorus, and potassium on the front of most fertilizer packages. But are they telling you the whole story, right? There are actually three other key macronutrients. Those include magnesium, sulfur, and calcium, like the calcium in our bones, right? And some of these start to sound like that old-fashioned saying, you know, what our parents used to tell us, we are what we eat, right? That rings some truth, actually, right? Hemoglobin in our blood has a core molecule of iron, which is one of the micronutrients. Chlorophyll in plant life on Earth and allowing for the process of photosynthesis to take place actually has a core molecule of magnesium, one of the macronutrients. Calcium is in our bones, again. So keep in mind, we get many of our nutrients from the soil, either directly or indirectly. And then also plants need oxygen, but what part of plants really also need that oxygen, right? Oftentimes it's the roots, it's the soil actually bearing some level of oxygen in its pore spaces as well. So soil is a matrix of minerals, organic matter, oxygen and other gases, and then water and living organisms. It's best to think about it in terms of a pizza pie chart, right? Think about mineral particles, the actual particles of the soil that are derived from the geological formations. The air in the pore spaces, about on average 25%. And then water, especially when it rains, right, that fills up those pore spaces, right? So just like you and me, our skin has pores, and so do plants, and particularly in plant leaves, the pores are called stomata. And then in soils, you have pore spaces that are actually spaces in between the particles. And this small slice of the pizza pie, so to speak, the organism's roots and humus, are actually organic matter. Remember, organic matter is something that is or was once alive. And if we were in person doing this workshop, I would actually ask you to talk that out, to spell that out. Organic matter is something that is or was once alive. And one way to think about organic matter also in terms of humus is that humus is long-term decomposed organic matter that's no longer really compost, but has finished gassing off for the most part and is now stable in temperature, right? So in thinking about organic matter, think about it as one way to improve nutrient and water holding capacity in our soils. Here's another image that's actually more or less the same as the pizza pie chart we just saw before, but the idea is to get a little bit more three-dimensional. So we've got some quartz particles as one example. Here's a clay particle as another. You've got air and water in our empty pore spaces, right? And then here we've got another clay particle and some organic matter. And the image is depicting micro colonies of bacteria, which we wouldn't normally be able to see under the naked eye. But the complexity of soil is really the key point here. And in thinking about this, we also want to have some understanding that it's due to the level of organic matter and the clay particles, both of which carry many negative charges that help with the exchange of nutrients with plants' roots through the water so that plants can uptake nitrogen, phosphorus, potassium, and calcium, and magnesium, and so forth. Now, in thinking about the physical qualities of our soil, right? And ultimately in this workshop, we're going to cover as an overview the physical, chemical, and biological indicators of our soil quality to have some understanding on ways to assess our soil and ultimately be able to improve our soil quality over time. For the purpose of this image, I want you to just kind of ignore the big gravel piece off to the left for now, right? When we're talking about particle sizes as it relates to soil and something called soil texture, one thing that we also dive into is the particle size itself, right? Sand being the largest of the three particle sizes, silt being sort of more in the middle, but much smaller overall, and then clay almost being invisible at this scale. And keep in mind that all soils are largely with proportions of sand, silt, and clay in percentages, in proportionality, in parts or fragments, right? So when you think about this over time, think about balance, right? Like everything in life, balance is a really good thing. If we have too much of one thing, like too much of that cake, right, after dinner, the potential for being a little bit full might be there, or having too much sugar, right? And so having too much sand or too much silt or too much clay can be potentially problematic because of how that contributes to our physical structure of our soil, right? And it also will affect the pore space in the soil as well, how well air and water flow through the soil. So at this point, I'm going to ask everyone to take a quick deep breath, right? Soil porosity is the percentage of a soil that's pore space or air or water, depending on if it's rained recently or you've watered your plants, right? The average soil has about 50% porosity, and sands have larger pores, but less total pore space than clays. And keep in mind that ultimately the volume and the particle size will very much affect how air and water flow through the soil. So think about that for a minute, right? Some soils are more blocky, like this one in the upper middle, or platy on the upper right. Others are more prismatic, like the lower middle, or more granular on the left, right? And how your soil is structured in terms of physical formation will actually very much affect how well air and water flow through the soil. So again, you want a loose, fluffy, dark, rich soil with lots of organic matter in it that will actually help you get bountiful blossoms and healthy harvests. So think about your structure in terms of water movement in soils. In soils with a good structure, pore space that occurs between what are called PEDs, the little clumps, right, in your soil, is relatively large and allows for water and air movement. A well-developed structure is especially important in a clay soil, in a very high clay soil, and clays with poor structure will limit air and water flow. You want to also make sure you read up about your plants and what your plants' needs are, right? What are your crops' needs ultimately in terms of what you're growing? There are indicators in the little labels that you will get about your plants when you purchase plants, or you can look up the varieties you're growing from seeds or cuttings, or ultimately also the bare rootstock you may be purchasing, to get an understanding of the soil needs and the plant needs for ultimately getting healthy plants, right? Some of the physical indicators of soil quality are among these here: the color test, the soil texture test, and the soil sedimentation, or sometimes called the soil suspension test, will give you a good sense of the physical quality of your soil and what you can do to improve on it over time. So we're going to dive into these ultimately, right? As you saw from the prior image, color is a key factor. For the most part, as a generalization, one visual test you can do is to think about the color of the soil, to look at the color of the soil. Is it a dark soil? As a generalization, for the most part, one can say that most soils that are dark in color have more organic material in them. And some other tests that you can do include the soil texture tests. These include particularly what I call the ball test, and then the ribbon test. These will help you understand how well water flows through your soil and the water holding capacity of your soil, the nutrient holding potential of your soil in terms of its fertility, and also the extent to which you can build on your soils in terms of weight-bearing capacity, right? So soil texture is the single most important physical property of your soil. And if you were to take a big handful of soil, wet it down thoroughly and consistently, and begin to do an exercise that can be at times very, very therapeutic. I'm going to ask you to take a step back, maybe think about how this is an exercise you can do with your neighbors. It's an exercise you can do with your family members, your children, the elders in your community. This first test, the imagery there on the left and the hand on the left, is what I call the ball test. It's taking a handful of soil, wetting it down somewhat thoroughly, and then sort of slowly massaging it into the shape of a ping pong ball or a golf ball, for example. And this is to give you a sense of how well the soil aggregates, how well it holds together when it's wet, and how well it holds together when it's dry. So everybody, please pronounce again the word aggregation. Aggregation is one of those key words, right, that will help you understand your soil quality, especially the physical quality of your soil. So now, if you were to crush that ball you had in your hand, right? Again, it's still wet, and it's formed a ball if it held together well, right? You could actually kind of slowly massage that soil in your hand, and you're going to get a little bit soil, a little bit dirty, you know, on your palms, on your fingers, and try to create what's called a ribbon, okay? And that's what this image on the right here, the top right, ultimately is. It's a ribbon. And if you were in the Midwest or in parts of the Central Valley, there's a very, very deep topsoil in many of those parts of the world. That's also why they call parts of the Midwest the breadbasket, right? There are deep topsoils with lots of long-term accumulated organic matter. And if you take a look at this image, you can see how dark that soil is, right? And that's an indicator again of the extent to which there's some level of organic matter in the soil. And then in parts of the Central Valley, parts of the Midwest, and other parts of California at times as well, if you were to massage out a ribbon, right, over time, and it's a very therapeutic exercise. It's also something you can do early in the morning when you go out into your garden or farm space, and just kind of, it's a meditative process, right? It's a way to connect with the earth, so to speak. And that ribbon, if it's got a good physical capacity to aggregate, to hold together well when it's wet or dry, will actually stay hanging over your fist just like that for an extended period as you kind of like slowly massage out that ribbon. And that's really a good indicator. That gives you a sense that the soil will hold together well, that it has the potential for holding nutrients and water well also. Now, the soil sedimentation test is a different kind of test. You would take a quart-sized jar, it can be glass or plastic, right? Just a fair warning, you might not use this jar for too many other things in the future, but it's a fun thing, exercise to do, because you can get one of these jars and actually do this exercise with your neighbors as well and get a sense of what kind of soil proportions of sand, silt, and clay they have, and do the soil sedimentation test by taking a big handful of soil from your garden or farm space and putting it into the jar, and then filling that jar ultimately with water, right? What you would do then is you would close that jar really, really tight. You want to make sure it's nicely closed so you don't spill any soil water onto yourself, your shirt, or even the kids if they're doing the agitating, the shaking of that jar, that bottle, right? You're going to take that jar, you're going to actually shake it around, right? And the particle sizes will actually fall out based on their type and size. The larger particles will fall out first, and then the medium size, and then the small. So we were talking about sand, silt, and clay before. One thing to think about is this. Do any of you remember when you were a kid and you would go to the beach on the ocean and go and dig a hole at the beach and try to create your own little mini pool and take your bucket, toy bucket, and run to the ocean and bring back water and try to fill up that hole to create your pool? Would that water stay there for an extended period of time, or would it sink down very quickly, right? And ultimately, that water was going downward, right? And in ocean beaches, you have a tendency to have sand at the ocean beach. Sand has a lot of pore space, as we talked about before. So in thinking about the soil sedimentation test and the layers that form in that jar, right? You would take that jar, you'd shake it with water and a big handful of soil in it. You figure that soil will fill up about half the jar, right? Before you add the water, and you'll shake it for about 2 minutes, and you'll get a number of layers that'll fall out. The first layer, in about 30 seconds to a minute, the first layer will form, and that layer is often the sand layer. Now, if we were in person, we would be able to do this exercise and you could actually see the layers form over time. The next layer, after about 3 minutes to 5 minutes, would be the silt layer, right? And then in about 30 minutes to up to 24 hours, you get the clay layer in the soil, in the jar forming. And you would take a ruler and actually measure the heights of the layers in the jar, and then do a denominator, right, over the total height and multiply it by 100, and you get a percentage. And we will email you upon your registration for this webinar the instructions so you can do this exercise at home, at your garden or farm space, or in your community or school or faith-based or therapeutic garden site, right? But the idea here is that you get a rough proportion understanding of the amount of sand, silt, and clay in your soil. Based on that, you may need to do particular things. In many cases, a lot of what you can do is add compost to your soil to improve your soil quality. If you have a very high clay soil, you may add compost to ultimately make it sort of fluffier and also increase the amount of air space in that high clay soil, so it's less tightly packed, because these particles are so small that they compact very tightly together, especially once they're dry. If you were with a very high sandy soil, right, there's a lot of pore space in between those sand particles. So you potentially add some compost there in order to make sure that not only do you have some pore space, but you also have additional surface area and the ability for the roots and the nutrients to tack on to each other in soil and water for the exchange of nutrients, so that your soils can be more fertile over time. Moving more towards and roughly equal proportionality of sand, silt, and clay. So in getting into then the chemical indicators of soil quality, we talk a little bit about soil pH, something called electroconductivity for soluble salts, and then cation exchange capacity. And in cation exchange capacity, we will actually get a test result when you get your soil tested. So I'm going to ask everybody if you could repeat after me, if you could. Don't guess, but test, right? So one of the key takeaways here is to get your soil tested, to actually get your soil tested, not only for nutrients, but also for soil pH, for heavy metal concerns like lead, for example, at the very least. And when you get your soil tested from a soil lab, you can actually also get the results on your cation exchange capacity as well. So diving in, right, what is pH? Whoops. All right. pH, in terms of soil, right, it's a measure of the alkalinity or the acidity of the soil. If you know anybody from the South, there have been folks in the past in my life that have talked about how sometimes there are sweet soils or sour soils, right? This is a reference to folks actually chewing on soil sometimes, which is not something we recommend here, but it's a reference to the extent to which some soils are more acidic or more sweeter or alkaline, right? So what are some examples of just foods that are more acidic or more alkaline? I'll give you some examples. One of them we tend to drink with our morning breakfast, right? Coffee tends to be more acidic, for example. Another on the more alkaline side, mothers produce it, right? It's milk. It's a good example. Also, how many folks here like to eat blueberries early in the morning, right, with their breakfast, right? The key thing here is to understand that certain crops like a certain pH, and soil pH is ultimately a measure that's a negative logarithm. Not to get too complicated in that, but for plants, right, this scale of 0 to 14 is a really big deal, right? Think of us as plants, as human beings, right? What part of our body is actually our roots? Probably our feet, right? In terms of the metaphor here we're going with. If our feet are in a more alkaline soil, right? you might be able to grow goji berries better. In more acidic soils, you might be able to grow the Ericaceae family, the blueberries, the azaleas, the rhododendrons, the American hollies, right? So soil pH is a measure that is a negative logarithm. And for a plant, the difference between a 6.3 and a 7.3, for example, right, is a really, really big deal for a plant. For us, we're using this simplified, humans like to simplify things. We're using this simplified pH scale from 0 to 14. And in the discussion about contaminants, when we get later into the discussion about contaminants, right, for the most part, if a soil's pH is way low, around, past a 4.5 or so, or way high past an 8.5 or 9, right? Either there's something wrong in how one's doing the testing, or there's some kind of major concern, right, for the most part. So think about soil pH as a measure by which, if we stay near the neutral zone of a 6 to 7, right, roughly, most plants on planet Earth like a neutral soil pH because that's most ideal for plant growth in terms of our plants' abilities to take up nutrients. Remember those macro and micronutrients we talked about. And for the blueberries here, they like a 5.5, whereas the goji berries, on the other hand, might like a little above a 7.3 or a 7.2 pH, for example, right? So here's where, again, doing your homework, right? Being the good neighbor, being the good researcher, understanding your plant's needs and your site's history in particular can help you ultimately to really grow your plants the best, to put the right plant in the right place and get bountiful blossoms and healthy harvests. So in thinking about soil pH, right? Think about your macro and micronutrients. These top 6 ones right here are the macronutrients, and these lower 5 right here are your main micronutrients. Now this image is a soil pH scale also, but we've truncated it, right? We've cut off the ends so that it's only between a 4.0 and a 10.0. And you can see, if you look between the 6.0 and the 7.0 here, most of the nutrients, their bars right here, right, are the thickest in between the 6.0 and the 7.0. And some of the micronutrients are a little bit more absorbable, right, by our plant's roots, a little bit closer to the 6.0, whereas most of the macronutrients are just right at the 6.5 up to 7. So that's why we say, for the most part, having a roughly neutral pH is a really, really good thing in terms of helping our plants uptake nutrients and ultimately getting optimal plant growth over time, right? So think about soil pH as a chemical indicator of soil quality. You can buy a soil pH kit from a local hardware store or nursery. Most Lowe's or Home Depots, or most nurseries certainly, and many hardware stores will carry a soil pH kit. If you buy a basic one, the rapid test one, for example, most of the time, unfortunately, depending on the neighborhood in which you are in, those will range from $8 or $9 to up to $12, $14, $15. And those will give you a rough idea of your soil pH. If you are doing this professionally, you may ultimately want to buy a more sophisticated electronic soil pH and electroconductivity meter in order to actually get more precise readings of your soil pH. And then in thinking about our nutrients, right? These are 2 images of a couple of fertilizer packages. And I don't know if anybody here uses synthetic fertilizers, but keep in mind that In many cases on fertilizer packages, they will give you a set of 3 numbers with a hyphen or a dash in between. Here it's the 1064, here it's a 23230. And in this case, we're talking about nitrogen, phosphorus, and potassium here in both of these examples. These are the top 3 of the macronutrients, but again, are they telling you the whole story, right? Are those all of the macronutrients? And are the micronutrients also referred to here? In this case, they're telling you a little bit more also about your micronutrients, the iron, the copper, the zinc, the magnesium. So you want to make sure when buying fertilizers, if you're going to use fertilizers, store-bought fertilizers, that you read the label, make sure you follow the instructions. And also ask yourself, are they water soluble or water insoluble? Does it say slow release, as in water insoluble, or more fast release, like a water soluble fertilizer? One example of a water soluble fertilizer is Miracle-Gro. When using water soluble fertilizers, one of the things that happens is that it's easy to very quickly over time wash away the nutrients further downward past the root zones because they are water soluble. So they're short and quick applications, but the soil, the nutrients that are applied through those fertilizers don't always stick around for long periods of time when they're water soluble or fast release fertilizers. In thinking about our chemical indicators of soil quality, in bigger picture agriculture, or if we fertilize extensively, one of the things we dive into sometimes are this concept of electroconductivity. This is most applicable when we're talking about fertilizing over time, over extended numbers of years or extended numbers of seasons. When doing so, sometimes if over applied, you can get the accumulation of what are called soluble salts. And for the purpose of this webinar, we kind of keep it simple, but basically soluble salts are a form of tying up fertilizers so that they're no longer actually accessible by the plant's roots, so that they're no longer uptakeable. So when you get your soil tested, you may be able to get test results for electroconductivity, or EC, and that'll be in a unit of parts per million. And in thinking about that, that's ultimately a measure to really understand whether you're over applying fertilizer or whether you're getting soluble salts that are the result of nutrient tie-up that are no longer actually available to your plant's roots. And electroconductivity is kind of a basic concept. It's running a current through water, right? And really having an understanding of whether you're getting salts accumulated over time. And then in thinking about chemical indicators of soil quality, right? The third main one is what's called cation exchange capacity. This is a measure ultimately of a soil's negative charge. Soils with strong proportions of organic matter or clay have a tendency to have some level of proportionality of a negative charge right on the edge of that particle. And this is, of course, microscopic. You can't see this with your naked eye, but this negative charge is a big part of what makes the exchange of nutrients between soil and plant roots through water possible in a soil solution. So really getting into improving your soil over time often means adding compost to your soil, and this can improve your cation exchange capacity over time. But again, a lot of this stuff is about balance. Having too much clay or too much sand can be problematic. It can affect your water and airflow and movement and drainage in your soil. Amending with compost over time is really, really key to your long-term soil quality. And doing so regularly is really important. If you were to take clay and actually amend it with sand, with the thought that you're increasing the porosity or the pore space, you actually do the reverse. You actually create a very, very hard material, some of which is what the original concrete was made from, right? Can plants grow through that really hard material? It's hard, it's challenging for plants' roots to do so. So keep in mind, amending high clay or high sand soils with compost is your best pathway forward over time. This is another image of the clay humus complex, that exchange of nutrients between soil particles and soil beds, those little clumps, right? That the roots wrap around in soils over time as they grow, and the ability of those nutrients to be let go by the particles and by the little clumps into the water so that plants can uptake them over time, right? This is the cation exchange at the root tip. So here are some examples of the clay or humus, that organic material, and that exchange of nutrients between them and the root zone over time, right? So ultimately, understanding how well your soil's physical properties are, what the soil pH is, and the cation exchange capacity can really impact how well your plants grow, whether you've got healthy harvests or blossoming and blooms, right? Over time. So basic concepts. Organic matter and also clay have a very large surface area. Incorporating, amending your soil over time with organic matter increases the nutrient exchange in the root zone. It'll ultimately increase the percentage of organic matter in the soil, which will increase the cation exchange capacity. All of this affects the soil's water and nutrient holding capacity for your plants to be healthy by growing in them. What are we talking about when we're talking about organic matter? We already said that organic matter is something that is or was once alive, but keep in mind there's organic matter throughout the planet, and also there's organic matter that over time was submerged into the earth over millions of years. Our fossil fuels come from ancient organic matter, ancient plant life that decomposed over time, and we now use as petrochemicals like natural gas and petroleum products for fuel, right? I like to tell people to remember organic matter by the acronym HONK, or honk your horn, right? Think of carbon as the backbone of most of our organic matter, from which all of the different branches branch off, right? So think in terms of organic matter helping to improve our soil quality over time, right? It helps to improve the fungal networks that hold the soil particles, the small micro clumps of soil you can see here, right? And ultimately increasing the overall surface area so that our soils remain stable and don't let our nutrients go down beyond the root zones. So think about how well a soil aggregates, right? How well it holds together when it's wet and when it's dry, based on how well the soil is in terms of the percentage of sand, silt, and clay, and the extent to which there's organic matter in the soil, and what the soil pH is, what the cation exchange capacity is. In healthy soils, your goal is not only a dark, rich, crumbly soil that holds together when it's wet and lets water go as it dries, but also that has proportions of stabilized organic matter that's no longer hot and gassing off, right? It's reached a stable temperature, that's decomposing a little bit at a time still to reach towards the organic matter. Fresh residues such as cover crops or cut off plant parts like roots that you've left in the soil to decompose over the course of the fall, winter, and early spring, right? And then living organisms that will help with keeping the fungal networks going and ultimately plant nutrient absorption possible over time. So basic concepts in terms of chemical indicators of soil quality, cation exchange capacity and soil pH ultimately affect our soil fertility, ultimately also by interacting with water and nutrient holding capacity too. You want a dark, rich, crumbly soil that holds water together well when it's wet and lets it go when it's dry. So that basic exercise of touching the soil every once in a while, right? Getting it to be a little bit fluffed up and make sure it's not compacted is really, really key. You don't need to dig down very deeply and turn the soil very much after the first 1 or 2 times when you're first turning the soil on a site. You may need to for the very first time when you're first working the site if the soil is compacted and has never been tilled before. But you might also find other things in the soil in urban areas, right? People that were in the construction industry sometimes dropped little things in there like soda bottles, PVC piping, rebar. When I worked with the New York City Housing Authority, we'd find all sorts of things in the soil back then. And then think about soils in terms of soil biological life, right? What are the organisms you can see in the soil, right? The worms, you might even be able to see the occasional pill bug or centipede or millipede, right? They won't go too far down, but worms will go a little bit deeper, right? And then what's the bacterial life? There are actually tests you can do to get your soil assessed for biological life. Dr. Elaine Ingham's work is really setting the bar and the standard for understanding soil biology. Soil biological life can really impact soil chemistry and the physical properties of our soil over time. It's really important, though, that you encourage soil microlife by amending your soil with compost over time as well. Continuing to add organic matter will help with upkeeping the amount of biological activity in the soil. And a good soil will also, in terms of its biological life, really help your plants to fight off of the negative plant diseases that sometimes want to impact your soil, your plants, right? Keeping them healthy over time. So this is an image of a root-feeding nematode trapped by a microscopic fungus, right? The fungus gives off a substance to ultimately attack the root-feeding nematode and will help the soil to remain healthy. So having a good, healthy soil will ultimately support your soil food web. Limiting factors of plant growth are nitrogen, but limiting factor for plant availability is carbon. And when thinking about these ratios, right, the extent to which you have got carbon and nitrogen in the soil, you start to think about what you might think about in terms of compost piles, right? What are the proportions of compost carbon and nitrogen in your compost pile over time? So think about ways to improve your soil quality. What are organic opportunities to do so? Some people will add manures to their soil, but it's very, very important that you specifically focus on herbivore manures. You don't want dog or cat manures. You want to note when you've got challenges around food safety from migrant animals coming through your farm or garden or yard space, right? So note, you got to be your best observer, your best researcher, right? You got to be aware of what's going on in your farm or garden space so you can keep your food, farm, and family safe, those you work with to provide your produce to, right? So if you notice scat from deer, if you notice coyote scat, mountain lion, cat's dog feces in your garden space, right? You want to keep your plants away from that, and ultimately you probably want to cordon off that space and not actually consume the plants nearby those spots, right? You want to improve your soil with compost over time. One way to also do that is not necessarily focusing on herbivore manure based compost, but actually also using deciduous tree leaves to improve your soil quality. Those leaves that fall at this time of the year, right? That's part of why we're focusing this week and next week on urban soils, is because it's the fall when the fall leaves fall from the trees, right? And then also next week is lead week, so keep that in mind as well. And by continuing to amend your soil with compost, a healthy compost that doesn't smell rotten, right? That is no longer gassing off, you can improve your soil's water and nutrient holding capacity. You want to think about whether you need to use organic amendments by getting your soil tested first. Blood meal and bone meal can be sources of phosphorus and nitrogen and other nutrients too. But you want to make sure you read the instructions on the package, right? And then we talked a little bit about soil fertilizers, right? And ultimately plant nutrients and water solubility when talking about synthetic fertilizers. But keep in mind, creating synthetic fertilizers in an industrial process has a fossil fuel footprint, right? There is embedded energy required to create synthetic fertilizers. So trying to stick to natural soil amendments when you can is a really good move if it's possible, right? To improve your fertility over time. Think about soil compaction, right? You don't want to step on your plant's roots if you can avoid it. Try to understand how deep your plant's plant growth needs are, how far laterally, horizontally, right, your plant's roots are growing. If they're fruit trees, you might have much more extended roots beyond the root, beyond the raindrop canopy, right? And then also think about root penetration and water infiltration, right? The ability for soils to not be compacted by not putting heavy weights on them, by not stepping on them, by not stepping into your soil beds like these raised beds, these mounded shapes, right? Will actually help water infiltrate and allow for porosity, the airspace in your soils over time. And then think about air temperature, not just the air temperature above the ground, but in the early spring and the late fall as the temperatures change, right? Especially in the early spring, that root zone temperature is really, really key to consider for as you dive in towards your late spring and your early summer to put your summer crops like tomatoes and cucumbers into the ground, right? A soil that's compacted is going to warm up much slower than a soil that's not compacted. So build raised beds, build up mounds if you're not going to use planter boxes. Keep your soil from being compacted by mulching your soils also. And there are many kinds of mulches. You probably want to, for veg crops, you want to use straw more than wood chips. You can use wood chips in your pathway and straw in your veg crop beds to keep the weeds down, to help with soil moisture, and ultimately to reduce upsplash of particles from the soil when you're watering. And you want to water using drip irrigation, right? You don't want to water using a hose standing there, right? Or a sprinkler dropping the pitter patter of drops onto the soil particles. Think about that for a second, right? If you have bare soils, that pitter patter will ultimately also bounce some of the soil particles up onto the bottoms of our leaves, right? Onto the leafy greens. And that's also where you have potential for exposures to lead if there's lead in the soil, right? So think about cover crops to improve your soil, interplanting and companion planting. We don't have a whole lot of time to get into these processes and practices, but cover crops can help protect your soil in the winter if you apply them in the late fall and reduce the amount of leaching of nutrients downward into the soil away from your plant's roots, right? And then think about your heavy metals, your lead exposure, right? Most properties where a building was built or pipes were put in before 1978 or 79 have lead paint or lead in the pipes, right? And so lead dust as it chips, if it's not been managed, right? Or if there's exterior preparation work done on the home or friction of windows can actually allow for chipping of what eventually becomes lead dust. That lead dust can land on the perimeter of your home, which might be a place where you have an accumulation of lead if the property was built on before the late 70s, right? The odds are that if it was built back then, before that time, before changes in the national legislation, then there was lead in paint and lead in some of the pipes and lead in gasoline, right? They talk about unleaded gasoline you might have heard of, right? And then bare soil in yard spaces where there has been a history of small amounts of lead contamination from chipping of homes and the exterior of paint on buildings can ultimately accumulate over time and contribute to soil lead in the soil that can be problematic. Think about your situation. Do you have pets? Do you have dogs or cats, right? Do you let them into the yard? Do they come back into the home? Do they roll around on the rug? Do you have young children in the home? Do they play on the rug too, or on the bare floor, right? Do they also put their fingers in their mouths? Where do your pets sleep, right? And how often do you let them out into the yard, right? So not trying to scare you, but I want you to think about pathways of exposure. And we will get much more deeper into this on October 27th when we cover safe soils in a more extensive way. But the potential for taking home lead dust by accident without necessarily recognizing it is there. And if you're in the construction industry in particular, and you're working on older homes, this potential is even greater. And I got to thank the San Francisco Department of Public Health and Garden for the Environment in San Francisco for these images and some of these points. So think about when you're growing food, right? Was there a windy night last night or this morning, right? When you're outside first thing in the morning, are you working the soil with bare hands? Are you touching your mouth because you've also got a cup of coffee that you're putting near your mouth? Are you a cigarette smoker and you're putting your fingers near your mouth, right? Do you have some kind of other container with a beverage in it? We won't talk about cold beverages at this point, but think about that pathway, right? You're taking that cup or that piece of food, fresh produce perhaps, that may have had dust from the wind from the night before if the soil wasn't covered, or if your next door neighbors didn't cover their soil, right? And the site was built on before 1978, and the potential for ingesting small amounts of soil dust that may have small amounts of lead on it over time, right? Risk is very much about the extent and frequency of exposure and the concentration of the contaminant in the soil or in the soil dust. So how frequently you're exposing yourself can be from a number of factors, and it's really a probability equation over time. So eating lead containing soil accidentally, that's on unwashed produce, or eating produce that is uptaken lead. We'll get into the pathways of how this all happens in the next workshop, can be concerning over time and can expose you and your family to small amounts of hazardous lead, little bits at a time. What are the concerns here? Well, lead toxicity affects health, brain development, dental health, can impact child behavior, placentas in young babies in the womb of their mothers, can harm kidneys. It can also ultimately affect our reproductive health as well, and also impact our calcium uptake and dental health over time. Children and elders are the most at risk, as well as fetuses, again, within the placenta. So possible sources, again, older homes, the demolition of buildings, right? And or small sheds that were built before 1978, 79, the history of industrial use. I want you to be your best educator, your best researcher. Look up Sanborn maps, look up the site history of your site, and then was the site built before 1979? What was the site's history previously? Was it a dry cleaner, a gas station, a junkyard? Was it croplands 50, 70, 80 years ago that is now an urban area? Was it a spot that was a 3 a.m. dumping ground for an unlicensed contractor that was doing work without insurance and licensing and not being careful about lead, or before we even knew about lead, right? So things to think about. Wear gloves, practice good personal hygiene in terms of not taking cups or food and putting it near your mouth if there was soil dust exposure potentials, right? If you're importing soils, buy Organic Materials Review Institute. Test your soil to make sure you've got less than 80 parts per million of lead. Don't let kids garden or play in soils greater than 80 parts per million of lead in California. Now, the soil science is evolving. The thresholds nationally used to be 400 parts per million in most of the rest of the country and 80 parts per million in California. But recently, the federal government, both the EPA, the Environmental Protection Agency, and the Food and Drug Administration have reduced the thresholds. California is still at 60 to 80 parts per million in range. And then be aware of sources of soil contaminants. Watch out for site risk. Do your research on your site's history. Be your good neighbor. Build planter boxes if you're going to build raised beds, but don't use pressure treated wood or recycled painted materials. Bring in new soil if there's any concern about soil quality. Use a landscape fabric or wheat cloth and add on wood chips as a potential layer in between like this, right? And then also amend with compost regularly. Use well-rotted manure. High phosphate manures like herbivore manures in our compost as it helps decompose will also help tie up heavy metals in particular. And some of the work done by the EPA in West Oakland using fish bone meal actually helped bind up lead in highly contaminated soil over time. People sometimes ask me about phytoremediation, remediating with like mustards and sunflowers. The soil science on that research is still evolving, but I will tell you this, in many cases, using plants to remediate soil does not give you consistent results in terms of depth and lateral horizontal extent of plant growth in terms of removing contaminants, and certainly has the potential to not remove all contaminants over time. So be aware of that when thinking about using phytoremediation as one opportunity. And then if I can help, I'm here to be a resource. Please don't hesitate to email me. The chances are if you email me, because this becomes a conversation very rapidly, I will probably ask you for a phone number and pick up the phone and call you and set up a time to talk. But keep in mind that staying safe, keeping your food, family, and farm safe, and growing your crops so that you have healthy harvests and bountiful blooms and blossoms is a consistent activity, a set of practices that you do over long periods of time. And we would want to really work with you to make sure that you're managing your food, family, and urban farm safely. So with that, I'm gonna exit out of the PowerPoint and take questions in case there are questions to be had. And that's my email address. I'll put it in the chat as well. Any questions? Feel free to drop them in the Q&A or the chat if you'd like. Looks like we're down to 4 participants, and it's April, Sony, me, and it looks like we have 1 attendee aside from that. I think that might have been April. All right. So that's it for now. I hope somebody pressed record at some point. Thank you. Thank you. Take care.